Hello, in this video, I'd like to talk about how to investigate the particular differential equation that you see in the video on section 1.1 about particular solutions and how to, in fact, check whether or not a particular function is a solution to a differential equation using Mathematica. So hopefully you watched this video where the professor talks about how to evaluate whether a particular solution is in fact a solution of a differential equation. So I'd like to show you how we can in fact find this solution and how we can actually verify it. So first, verifying it, which is really the topic here, in addition to the fact that given a particular initial condition to determine the value of C. Okay, so how do we go about doing that using Mathematica to speed things up? So let's do this one at a time. So first of all, we have this function y of x is equal to a constant. Let's call it C. All right. Now I'm going to call it a lowercase c because it's actually not a constant for us because we can change it. It's called an arbitrary constant, but for Mathematica, it's technically not a constant. So I'm just going to keep it as a lowercase c and multiply by x cubed. All right, so that's the function. So if we, in case we want to know what that is, there it is. Now, what we have to do is plug it into the differential equation. Now, the differential equation looks like this, right? X1 prime minus 3y equals 0. This is not how we can, we're not allowed to enter this expression as it is into Mathematica because it'll be confused. First of all, it will not understand that we have x times y here because it'll think that this is a variable called c or something like that. And then second of all, it does not expect c to be a function because it's not in function notation, so it's not going to be able to take a derivative of that. And notice the blue. That means that it's treating it as a total variable. Now, this one here, it recognizes that y is already a function. That's why it's not in blue. But these two, it hasn't recognized that. Now, to fix this, what we need to do is just put a asterisk to emphasize that we're multiplying. So we're doing x times y. And then, of course, we want to emphasize that we're doing a y of x, and we're taking a derivative of y of x. Okay. And finally, we don't want to use a single equal sign. We want to use double because, again, what we're doing is we're testing to see whether it's true. And so there you go. We have a expression evaluated, as you can see, as it is. You can see that we have made another mistake. The prime is not supposed to be here. It's actually supposed to be over here. So that way we get what we wanted, which is true, indicating that in fact this expression or rather this function is the solution to this differential equation. So we have to make sure that we're entering the differential equation in the correct way. Otherwise, we won't be able to evaluate it. Now that we know, by the way, if we had, instead of called it C, if we had put in a specific number, right, we can evaluate it again by just clicking the cursor there and hitting Shift Enter. We get the same result. We get true. You can see the outputs changed from 59. They're now 60th output here. So what if we wanted to actually find this solution, right? And we had the differential equation. How would we do it? Well, we would use dsolve. We would enter this expression as it is. Okay, and we would say we want the dependent variable to be y and the independent variable to be x. So it's getting confused. Well, this is because y has already been defined, right? Remember, we talked about how we need to make sure that we're clearing our variables before we ask. Okay, So now it was able to evaluate it after clearing. Notice even though this command is underneath, it's still okay, because you see this is on the 62nd input, whereas that was 63rd, which means that when you enter the 63rd input, it already has evaluated this. So as you can see, the solution is y equals constant times x cubed, which is exactly what our equation was right from the beginning. All right, finally, one of the other things that happens in this video is that, as you can see, we're given an initial condition that x is a -3 and y is 2. And of course, the question is, when x is -3 and y is 2, what would c equal? Well, basically, this is very simple. It's basic algebra, right? Where you're plugging in -3 in for x and y 2 for y, right, into this expression. So once again, y of x is, let me define it, and once again, is a constant c times x cubed. And you can see why, in fact, we had to use a lowercase c. That's because it actually isn't a constant, it's technically a variable. That's because it could change, right? So whenever we're programming, we have to be even more careful than the way we talk in mathematics, right? So in mathematics, often we say, it's an arbitrary constant. Well, it's not really a constant, right? It's not a fixed number. In fact, it can vary. It's just not an independent variable, that's all. So, but it's technically not a fixed number like pi or the Euler constant, which are true constants. Okay, so we have the function here, and we want to basically plug in -3 for x and 2 for y. And this is very easy. All we have to do is say we're going to solve. We want to let x equal -3. So we're going to plug in -3. I'm going to say let it equal 2. And we want to solve for c. Okay. And just as it does in the video, so as you can see in the video, the professor finds that c is equal to 2/27. Standing in front of it, but there it is. It's negative c, excuse me, negative 2/27. So so you could see that we have found the solution as well. So this is how you would use Mathematica to, first of all, verify whether or not a particular function like this, all right, or like this, is a solution to a given differential equation. And the way you do that is simply just plug it in. Literally, you just type the differential equation, and it'll either say true or false. The second was, what if you have the differential equation, you don't have the solution? How would you find the solution? Well, this is how you would find it. And third is, well, let's say you do have the solution and we have a specific initial condition. Can we find the so-called arbitrary constant, which is not a real constant, but well, that's what we call it. And this is how you would do that. Okay. So one question that may arise at this point for you is, well, why am I taking a course in differential equations if I could just use dsolve, right? Well, why even bother? I mean, this is because this is a game changer, right? I mean, all of the equations can be solved, and why are we even bothering with this course? And the answer is, well, not every equation can be solved using Mathematica. And as you will see very quickly, some of these equations get very, very complicated, and many of them have implicit solutions. And so these ones will not be solvable. We do need to use techniques. So Mathematica will help us get there using those techniques, but simply just plugging it in will not always be possible. It will be only possible for some of the easier differential equations that don't require complex procedures. And second of all, of course, we want to understand the how to apply differential equations to solve real world problems. And this, again, Mathematica cannot help us. However, it is important that you do learn how to use Mathematica, because it'll give you a great advantage during exams when you are actually allowed to use Mathematica. All right. Thank you for listening.